Hello everyone, today we are going to talk about graphs, a structure that is used in many computer science problems. Let's talk first about some definitions. A graph is a representation of relationships or connections between pairs of elements, usually called nodes or vertices. Formally, a graph is a set of vertices and edges that are the connection between these nodes. Each edge is a pair representing a connection between vertices. We have here, for example, the pair AB that represents that A and B are connected or are adjacent. We have here the formal representation, the sets that represents a graph, and the graphical representation of a graph. We have here a set of 5 vertices and a set of 7 edges. We have pairs here indicating, for example, in this case, that the vertex 1 is connected to the vertex 3. Let's talk now about how we can classify these graphs. The first kind of classification can be related to the edges. We can talk about undirected graphs, that are graphs where edges are represented by lines without indicating a direction. In this example, we have that 0 and 1 are connected or are adjacent, and again 1 and 0 are also connected. So in this case, when we have an edge, the nodes are adjacent to each other. This is not the case of the directed graphs. The directed graphs, in this case, the edges are represented by arrows, and this indicates the direction. In this example, for example, we have here a directed graph, and in this case, 0 is adjacent or is connected to 1, but not the other way around because we don't have this edge. We can talk about weighted graphs if we include values in the edges that will represent weights or costs, for example, distances. This is used in many algorithms in order to compute, for example, the best path. Let's talk now about the degree of a vertex or a graph. For a given vertex, we can distinguish the in degree, that is the number of edges coming into V, the out degree, that is the number of edges coming out of this vertex, and the degree, that is the sum of these two concepts. In general, the degree of a graph is the degree of the vertex with the maximum degree. In this example, we have the node 4 with an out degree of 1, because it has an edge coming out of it. We have the number 2, the node number 1, that has an in degree of 2. In the case of 3, we have a degree of 3 because it has 2 incoming edges and 1 outgoing edge. Let's talk about path, cycles, and loops. A path is a sequence of vertices traversing edges. This is represented by a sequence of vertices, and we can talk about the length of the path, that is the number of edges on the sequence. A simple path is a path where each vertex is different, except maybe first and last. And a cycle is a simple path that starts and ends in the same vertex. We have also loops that are cycle of length 1, that contains only one edge. Let's see an example here. We can say that we have here a path that could be 0, 3, 4, 1, 0, 3, 1, 4, 3, 0, 3, 1, 4, 3. Here we are repeating the 3, so this is not a simple path. We can define, for example, the path 0, 1, 4, 0, 1, 4, that is a simple path. we can talk about a cycle if we consider 3, 1, 4, and 3. 3, 1, 4, and 3. Here we have a path that starts and ends in the same vertex, and we can see here a loop in the case of the node number 5. That is a path that looks like this, with only one edge. Let's talk about the connectivity in graphs. A vertex A is connected to B if there is a path between A and B. We can talk about connected components that are sets or subsets of vertices that are connected to each other. And in the case of directed graphs, we can talk about strongly connected components that are graphs with only one connected component. For example, here we have 1, 2, 3, and 4 connected components. The 0, the number 2, and the number 5 are isolated, but 1, 3, and 4 are connected to each other, because you can reach from 1 to 4 to 3, and the same with the other vertices. Here we have a strongly connected graph, because we can reach from one node to any other node in the graph. So this is what we call a strongly connected graph, because it has only one connected component. Let's talk now about the sparsity and density of these graphs. This is related to the number of edges. If the number of edges is almost equal the number of vertices, the graph is sparse. This means that there are many isolated vertices, or they are likely connected. If the number of edges is almost equal to the square of the number of vertices, the graph is dense. This means that the number of edges is close to the maximum number of edges. This will impact in how we represent the graphs in our code, as we will see in the next section. Thanks for watching, and see you in the next video.